Feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you can make me move. You can make me move. Can make me move. You can make me move. Can make me. So alive, make it last forever. Stop in time, yeah, I'm surrendering. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you can make me move. You can make me move. Can make me move. Can make me move. You can make me move. Can make me.
Hey guys, how is it going? Um, Many of you might be wondering why I'm speaking in English, right? And um, and I'll get to that. But first, since my last live streams were all in Spanish, um, some of you might have missed out on what was happening on the previous lives, or didn't understand where it was happening. And so I want to reintroduce myself, right? To to make clear what was happening these previous days for the new people who's not Spanish, okay? So my name is Gabriel. I'm 18 years old. I'm a software developer. Specifically, I work with low-level systems and stuff. And more recently, I started also with distributed system stuff. Um, and my main project, the project that I'm currently working on, is called Hemitheos. Hemitheos is a bare metal hypervisor for the ARM architecture made in Rust. Okay, and this was the project that I was doing these previous days. Okay, um, anyways, you can watch out the previous streams, um, and if you don't know Spanish, you can um, set the subtitles, okay, to English. I um I remember that the first live the subtitles are wrong when I was speaking, maybe because the microphone was like kind of weird. I don't know. I somehow fixed that when I changed the mobile. Okay, because I recording with another mobile. Okay, so well, that's it basically. Um, before we even get to start, I would say I will apologize, okay? Because my English level currently is not that good, and I know that it can be tough to understand some things of what I'm currently saying, right? So that's why I'm apologizing previously before we start. Okay, I'll try to improve as I do streams. Okay, but I can promise I will be an expert in the short term. And even now, I'm having trouble with the pronunciation with some words. Okay, um, that's it. I will try to improve. Okay. Um, so that's basically it. Uh, Without further ado, let's get to the actual work. Okay. Um, uh, Let me check out the live stream. Okay. I don't know if the audio is good. If you guys can hear me out. Um, okay, it's perfect. Well, I think it's perfect. I don't know. I don't really know. Um, um, I will put the desktop. Sorry, guys. You know that for somehow when I speak in my mind, somehow when I speak in my mind, it everything sounds good, right? Like um, the pronunciation I have in my mind when I'm speaking to myself is just like a C1, but then I go to the actual word. My mouth is just like constantly uh, biting biting itself, right? So I don't know. I have to a lot of things to improve. Um, 1 second, okay. Let me put here. Um, okay, perfect. So I will go to Hemitheos. I will open the project. Okay. This I'll explain what I was doing the previous day. Okay. So anyways, the project is a public repo, so you guys can go to the. I will put the link on the. I don't know if in the description of the channel of the or the description of this video, but you guys will see the repo if you don't know how it's the state of the project currently. Um, anyways, you can watch the previous lives as I mentioned before. So, no problem. Okay. Um, so the thing was that I was doing this function over here, pt update entry. Okay, and we go to the same function, but in Zen, we'll see that what it does internally is basically, let me search for it. Okay, here. Okay, what it does internally is, well, it takes this it sets the machine frame number to read only. I'll explain what the reason why Zen does that. Okay, that's a security issue. Well, um, it's not exactly on a security issue. It's more like um, a parallelism issue, or I don't know. I'll explain that later. But first, we can see that the first function that Zen calls is this Zen PT next level. Okay, and if we go to that function, we can see that what it does is basically get this entry. Okay, and it takes the current address of the current table. Okay, and it adds the offset. Okay, and then they pass this entry for this to this. I think this is a macro. I don't really know. I have to check that. Um, and then they go and they map the table. Okay, the previous table, the previous reference to the table, because they then map the current table. Okay, um, why are they doing this? Okay, so the thing that they are doing this is because um, they need to get to the last level. Okay, to get to the last level, what they do is basically temporarily map tables. Okay, um, and map constantly until they get to the last table. Okay, and another interesting thing that they do here is this is this thing. Okay, there is basically let me check out this 1 second. Okay, so uh, no, this is not the what I'm looking for. What I'm looking for is I think I lost the function I was looking for. 1 second, guys. Okay, yes, this is not also. No, this is not what I'm looking for. Okay, let me copy this, search it manually. Okay, type search SMPT update. Okay, I'll go here. And let me copy this. Okay, so SMPT update entries is, I think this is where I'm looking for. Um, uh, um, uh, mm, calling this? Okay, I think it's this thing. It's not exactly this. Okay, I think this function. Okay, is this same PT mapping level, and this we're looking for, I think. Okay, yeah, this is it. Okay. Okay, so we see here, this is the function that I was analyzing yesterday. So what they do is use this likely macro, okay? And I was trying to figure out what this likely macro does, okay? Does, and that's because I already know when I looked at the definition of the macro, okay. We go here. Well, I don't have this here. Maybe it's okay. When we go to the definition of the macro, we see this, okay. Built-in spec. I was like, what the hell is this, man? I never seen something like this before. Yeah, and this is not usual. It's a GNU extension, okay. Like what it basically does. Well, I'll explain what it does, but first, we need to make clear what it basically receives here, okay? Because you are seeing this, but it's way simpler what you than what you are probably guys thinking. So the two exclamations, just in case that you don't know what it means, are basically to convert an expression to a Boolean expression. Okay, so if, for example, we have double exclamation null, it basically will return 0. Okay, or for example, if we have double exclamation 5, it will basically return 1. Okay, or we have, for example, double exclamation 0, it will basically return 0. Okay, since in C we don't have Boolean values like in other languages, and that's why basically. And now what it does internally. What it does internally uh, is kind of complex, but at the same time it is easy once you see what it does. So what it does internally is that, for example, I took this code. Okay, I will move this code here. So for example, imagine that that we have this. Okay, so the first argument that we receive in this extension, okay, because this is an extension, the first argument that we receive is this comparison. Okay, x equals to 3. We expect this expression to be false. Okay, in most of cases this expression will be false, and that's where we are saying with the second argument. Okay, and if it is false, okay, it will basically go to this else, and it will go to the to this var function. Okay, in case that x is not is equals to 3, it will fall to this function over here, foo. Okay, so that's what it does internally. But you might be thinking, if I can, for example, do this uh, instead of instead of doing all this stuff um, with all these extra words in the mid, why don't I just do this, right? And the main reason is very simple. Okay, uh, and we have to see a little assembler to um, to see where how this internally works. Okay, because at first glance it might seem like this code does exactly the same, right? But it doesn't. It doesn't. Okay, it does not do the same. So uh, I will put a little a brief comparison here. Okay, of the assembler codes. So if we see here how this compiles, okay, the compilation would be something like this. It's not exactly this, okay, if you put this on C code and you compile without optimizations, okay, the generated code won't be exactly this, okay. This is an example for explaining this concept, okay, this concept. Uh, so uh, so the thing would be, uh, what we do first is we compare it x to 0. Okay, it makes sense, right? We compare it x to 0. Well, this isn't exactly a code where I think I confused. Yeah. This is not corresponding to this. This is reversed, guys. This would be here or no? No. Wait. Hold on. 1 second. I don't know. I don't know where is a 0 here. I don't know. Okay, so let's change the comparison to a 3. Okay. Um. Uh. First, we make a comparison to 3, right? And it makes sense. Okay, we compare it, and then if x is not equals to 3, okay, uh, then we'll fall to this foo or label, okay, and then we will call foo, and then after it, okay. um Let me check out where this would be actually if it's equals, okay. Yeah, this would be actually if it is equals, okay, to 3. Okay, so if x is exactly equals to 3, we'll fall to this label, okay. Well, we'll jump to this label, okay, and then we'll call full, and then where it comes next, right? um and the other code, and the compared code would be this, okay. uh we compare it x to 3, and in case that they are equals, we have to var, okay. um let's check let me check how this, okay, this would be okay, guys. I think I just mixed these codes, I don't really know. I think I just mixed all of these codes. And this would be actually, it's not equals. Okay. And we fall to full, and then we go to bar. Okay, yeah. That would be it. No, it would be actually, so they are equals, you go to bar. Okay, yeah. Would be like this. Okay, so if they are not equals, they go to full. Okay. And here, okay, yeah, now it's correct. Okay. Okay, so I'll explain because I was checking out this code because I don't know, I think I mixed just some things. So where it does internally, okay, this compares x to 3, and then if it is equals, it goes to full, and this calls full, and then after it, okay. And the other would basically compare x to 3, exactly the same thing. Go to bar in case that they are equals, okay. This would be the opposite to what we were doing, okay. In this case, we're comparing if they are equals. In that case, we're finding to full. And in this other case, we are comparing if they are equals, and we're finding to far, okay. No, this doesn't make sense actually. Wait, hang on a second. I think I just pause x to 3. Um, okay, so what we are doing here is not exactly correct. Okay, a ver. This would be x is equals to 3 won't be the case in the most of the times. So in case that we go to, okay, that makes sense. Okay, so okay, this would be they are not equals, okay. Yeah, this would be they are not equals. Okay, so you guys might be thinking, okay, this is exactly the same thing, right? um it actually it is actually not the same thing, okay. That's because if we see the pipeline of a CPU, okay, we have 5 steps, okay. On the first step, would be this fetch. Okay, that would be basically the program looking at the next instruction that it has to execute. Okay, and and usually in a fetch, the CPU internally saves uh, the undecoded instruction in the cache. Okay, so um, and we have to understand that when we are executing a program, for example, if we are in this comparison, okay, and is in the execute step, okay, if we are executing this, we won't wait until this completes, okay, the entire pipeline to fetch the next instruction. Okay, the CPU will fetch as much instructions from here on as it can. Okay, so imagine that the CPU, for example, takes all this block. Okay, of instructions. It fetches all of this block of instructions. Okay, and um, and what's the matter with this? Okay, so what's the deal with this, right? So what happens is that basically what this built-in spec does is basically tell the compiler, okay, in the most of cases, this expression, okay, that we're evaluating here will be false, okay, and in case that it isn't false, will fall to this code over here, right? Um, so internally, it can optimize this to get exactly the code that we're looking here. So when we get to this comparison, okay, in the program, um, the CPU will fetch all of this data. But okay, so uh, in this case, bar would be the function that we execute the most of times, okay, right? So fetching all of these block is correct because in most of cases, we'll fetch this data and use this data, okay? We'll fetch these instructions in this label bar and we'll use these instructions, okay? So the CPU doesn't have um, what we call cache misses, okay? Um, and if we go to this other code, okay, we can see that uh, if x doesn't tend to be 3, okay, if x doesn't tend to be 3, okay, um, it won't generally execute this code, right? So we compare here this x2 3 and we fetch the rest of the code, right? What's the deal here? We're fetching all of this code and we will probably not use it, right? So the CPU is recollecting in cache all of these instructions that won't probably use, right? So that's why this code is um, most efficient. Okay, it has a better performance. Um, the modern compilers usually optimize all of this stuff, okay, internally, but environmental environments, we usually have to do this kind of optimizations manually. Okay, so that's basically how this built-in spec works. Okay, uh, it generates a code, an assembler code, optimize it in way that the um, that the that the usual code that will execute will be this. So the CPU will fetch all of this. Okay, it will basically make cache misses because we are not fetching unnecessary data, unnecessarily data like we do with this full thing here, right? Like we do with this full here, right here. Okay, so that's what it does internally. Okay, um, they usually define a macro that is called likely. Okay, this macro that we can see here, where's the macro? Oh crap. Here. Okay. um so what this macro does is call this built-in spec, convert this expression to a boolean expression that we mentioned before. Okay, this double exclamation, and check if in this case is it's true, right? So so that's what it does internally. um I was doing some research to find something similar in Rust, and then I found this. Okay, this function likely from the core. Okay, because we don't have std, so we have to use all the functionality that comes from core. Okay, and I found this function likely. But the problem with this function likely, okay, is that um, it belongs to the nightly version of Rust, okay, which means it is not stable. So um, we might consider avoid this, okay, and instead use another alternative. Like for example, one that I found, I don't know it. Oh no, I didn't save the link. Crap. Well, one that I found was this. Okay, this directive over here. No, this doesn't explain. Okay, this directive over here, right? That this guy is explaining, called. And called, what it does internally is basically say, okay, this is the function that generally won't be executed, right? So try to not to put it on the first lines of the next instructions, right? And we have to combine this with this inline never, because you know, if we don't set this inline, it will basically put the raw instructions and will fetch more unnecessary data. Okay, so that's what it is. Okay, um, and I don't even I don't even recall why I was doing this likely function. Uh, uh, Let me check out this. Oh, I forgot. Uh, hmm, forgot. Shit. Oh shit. What was that? Where is it exactly? This. Oh, this we're looking for. This also we're looking for. It's not what I'm looking for. No, I'm not looking for this. No, this is not. So, um, okay. Sun PT mapping level. Okay, this was where I was looking for. So we go to here. We start this. Okay, we'll see that it's using this likely. Okay, because the level will likely be the level 3. Okay, the mapping. So one of the first things that we would be doing would be this function, okay, pt mapping level. In this case, we will call it pt mapping level, just that. So yeah, before we even get to this pt update entry, we should first do this pt mapping level, okay. So yeah, I will start with that first. So I will go and put here our function. Okay, I will basically be let me think. I will go and set this function over here. That would be pt mapping level. Okay. And we return the current level. So assign it int of 64 bits. Okay. So what arguments do we need? Virtual frame number. Okay, so we need this virtual frame number. I will name this as virtual frame number. That will be basically a virtual address. I also need this machine frame number. So the same thing here. Machine frame number. I also need this number. I don't know what is using this number for. Let me check. It is not using the number, right? Okay, yeah, it's using the number. So I think that the number would be the current level, right? The number would be the current level. That's what I'm thinking of. Yeah, probably. The number would be the current level. Yeah, I think it's that. Cycling the flags. Okay, this same thing here. Unsigned int of 64 bits. Okay. So okay, then we need to check this thing, right? Machine frame number is equal to invalid machine frame number. I have to look for this definition of invalid machine frame number. Okay, so if we go to the definition, it would be basically invalid machine frame number raw. So we'll copy this. I don't know what this npm share underscore npm does, but I think it's more interesting now to see this. Okay, this is negating sign a thing, right? Oh, I'm stupid. I had this definition here. I had this definition here all along. Okay. No, it's not. I need to see this. Okay. It doesn't do anything, actually. It's not doing anything. Yeah, it's not doing anything, right? So I don't really know what this don't take into account that we're removing mapping. Okay, so I don't know where is using this mask here. I don't really know. Okay, let me check the the space block. Okay, so it's moving this. Okay, so still uh, still in the left chip, but how much would be 128? Uh, 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 basically we pass these two binary. This is applying an AND operation to these flags and the page block, right? Should be the 1, 2, 3, 4, 5, 6. Yes. Okay. So an argument taken out. We had here the definition. So no problem with that. No, it's not. It's not. It is here, I think. No, it's not here. Where was it? It was here, right? Yeah, it was here. Superpage mappings is allowed. Okay, so it's checking for these superpage mappings, right? Uh, so likely there won't be superpage mappings. What is this thing, superpage mappings? I don't actually know what this means, superpage mappings. Where is this? Superpage mappings. Tiny that groups contiguous smaller memory pages into larger single pages. Map memory with vertical replace a look-aside buffer. Okay, I think I know what this means. Okay, so I think that I know what this refers to. Okay, so oh no, yeah, hold on. Maybe um okay, so let's bring this. Case that the flags. So in case that this bit here is 0, value will be 0, right? It's name this. Okay, I think it's same thing as unlikely. Okay, I think what it means. I think I understand what it means, but I have this here, this bit. I will basically give okay, so it's assuming that it has the super pages enabled. Okay, we just multi-car reverse block mapping. Yeah, okay, I think that I get it now. So expression is likely to be I already know. We have this value here. We compare the flags and it always be 0, right? And if it's 0, we negate with deny that thing. No. 0. So this would be the equivalent to okay, I think I get it now. I think if we draw this, maybe it would be better. So we have, for example, this page block, okay? On this page block, we go to the definition, it's basically this value, okay? This value over here. So flags are, I don't know how many fields are in, okay, 9 fields in flags, right? So imagine that flags would be this value, okay? 0, 0, 0, 0, 0, 0, 0, 0, 0. And imagine that we have this thing, right? Okay. Okay, so imagine that these are the flags, okay? We're doing an on operation here. This would be the, this would be the, this would be the page block, okay? Okay, all right. So we have here page block, and this would be the flags, okay? So these are the flags. Okay, and this bit corresponds to the super pages bit. Okay, there is a functionality that I will explain now, but first let's say that it corresponds to the super pages. Okay, super pages mapping, right? And in the expression we're checking, we're negating this thing, right? So imagine that we enable this in the flags, okay, that we enable the super pages mapping. This would result on this, I will copy this, just a moment. This would result on this, okay? Do we agree? Do we agree? Okay, so this would result on this value, okay? And this value, we're applying a not operation to this value, right? So now if we apply a not operation for this value, it will be basically this result over here, right? That is basically all of this, right? A 64-bit value, huge, okay? So in the likely, we're taking this, so Boolean expression, and a Boolean expression would be 1, okay? So so it's true, and it goes to the, so what this means is basically that if we have the super mapping enabled, the level will always be, also will be always 3, right? Um, so uh, so that's it basically. If we have this feature enabled, the level will be always 3, okay? In the other cases, well, first we'll do this case, right? And that we understand how this case works. So let's say if likely, but we can't do this likely thing because we don't have this. Okay, what we would need, what we would need to do, yeah, well, what we would need to do is this else ifs, the functions that check this and that are checking this, put them with the called thing that we saw before. So yeah, that's what we need. So I will first define this page block. So let me open another tab. Okay, I will open another tab. To use this. Okay, I will define these two macros. Okay, so I will define the page block thing. I will define it on the page. Yeah, in the page thing. So I will define it here. Okay, so this would be the value. We need this one on this page block bit, right? So put here. Let me put some music, okay? Basically, okay, so it's block with okay. Okay, so but I don't really know if this contiguous thing is the same as the super page mappings. I don't think it's the same thing, right? Yeah. Mine super pages transpile the application involves like distinct levels: physical super page allocation, physical super page preparation, super page mapping creation, super page mapping destruction, and physical super page relocation. Here one illustrates life cycle of super page in terms of this section discusses the trade-offs between the possible choices, including those made by production and prototype systems. 1, 2, 3 are how handle these events. This can just okay for the okay. I will explain this contiguous thing, okay? This contiguous mapping, right? The contiguous mapping would be basically a way to store less data, less mappings in the TLB, right? The translation look-aside buffer that we know. For those who doesn't know the TLB is basically limited region on the CPU where we store translations from virtual addresses to physical addresses, right? So that way the CPU can access them faster than fetching it to the RAM every time, right? So imagine that we have 3 entries, right? We have the entry 1, we have the entry 2, we have the entry 3, and that's it. So imagine that this entry 1 has the flags X, okay? Imagine that this entry 2 has the flags X also, and this entry 3 has the flags X as well, right? So imagine that there are all zippers between 4 kilobytes, okay? Kilobytes. Well, I will try to more or less do this thing. 4 kilobytes and 4 kilobytes, okay, of separation between all the blocks, right? Well, so if we know that, we can enable one feature on the mapping, right? In the addresses, we can active a bit that would be this bit over here. Let me 1 second. No, this is not the bit I'm looking for. No, I lost the bit. Where is it? Okay, let me check it out. Okay, so we can activate this bit, right? The contiguous bit. And the contiguous bit would be basically a bit that when it's enabled, what it does basically is if we have these three entries here that we know that they are all separated between 4 kilobytes, and if we know that um, they all use these flags X, the same flags, okay. uh, what the TLB can do is basically, instead of saving every entry, individual entry, right, which would mean that we save, for example, entry 1 to a physical address, then we save the entry 2 to a physical address, and then we save entry 3 to physical address, right? So instead of do this, that would basically store 3 multiplied by 8 entries, and by 8 bytes, sorry. We can define a range, right? Because we know that they all use the same flags and they all use the same separation, right? So we can say, okay, we have from this entry 1 to the entry 3 with these flags, or no, the structure would be entry 1, entry 3, okay. And it would basically will be basically, instead of saving three entries, we would be saving 2 entries, right? Which would decrease the size of the data that we are saving in the TLB, right? So that's basically how this optimization works. It's pretty simple. If we had, for example, instead of just 3, we have entry 4 with the same flags. We change this for 4 in, so it would be from entry 1 to the entry 4, okay. And we are saving 2 entries instead of the 4 complete entries, right? So that's why it's important to check the flags, okay? Because if one entry has a different flags, for example, let's say that it has the flag and that the entry 2 has the Y flags, right? The TLB will treat this entry 2, okay, that calculates adding 4 kilobytes in every step. It would basically treat this entry 2 as if it had the flags X, right? Which would mean which would end in a security issue or a functionality issue in the program, right? So that's why we have to check the flags. They all have to be the same flags. So that would be the contiguous thing, but I don't really know if the contiguous thing is the same thing as the super mapping. I don't actually know. But yeah, what were we doing? The page map thing, right? Yeah. So we go here and we'll check these flags. How would you evaluate an expression as a binary expression? Can we use this double exclamation in Rust or not? Let me check. Flags and page block, right? So it would basically be this thing. I will search for the in Rust for the double exclamation in Rust. In Rust, it's not a single in operator. Instead, it's simply two separate logical not operators. Another way to convert a true and false value to a strict boolean, similar to double negation in other languages. Okay, so it's the same thing, right? Okay. So we can use it without any problem. Okay. This would be the first validation. Okay, and have to put here the level that would be an assigned int of 64 bits. Okay, so the level here would be equals to 3, right? So the next thing that we need to check is this first order that I don't really know what it means exactly. I don't really know. But first let me check this mask thing. Don't take into account the machine frame number when removing mapping. An example, machine frame number invalid. To calculate the correct target order. This would be the machine frame number. Comparing this. Yeah, I think this is comparing to the machine frame number. Where is this machine frame number X doing? Okay, I want to see the definition. Oh, it's nothing. It's not doing nothing. Anything. Okay. So okay. I want to check this invalid machine frame number. Okay, 10-0. That would result on all on. Yeah, this would result on this expression. I don't actually know where it is comparing this value to the motif frame number. Motif frame number won't be ever this value, right? I don't know. I don't also know where is this thing. Okay, guys, so I have to go for a few moments. I will be back like in 60 minutes, maybe less, I don't know. So I will be back in 60 minutes.
Open eye, feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you can make me move. You can make me move. I'm alone, I'm a broken home. I gave you all the bricks that I own and know. I'm letting go, I'm breaking these walls down, breaking these walls down. If you want adventure, then fly to home. But if you wanna travel, then go alone. Yeah, what's the point in us if I never know? Yeah, if you're gonna leave, I'ma let you go. I'm tired of the pain. Go away. I'm tired of yesterday. Fada, fada. I fell where my demons dwell. My own little nightmare, I call it hell. Oh well, it's time to get back up. Climbing and climbing, I'm done with this ride, is what I tell myself, so I could feel something else. Yeah, I guess I had my bad days, but it doesn't mean I lost my style. Darling, where were you when my heart was on the ground? I thought time would prove that you would stick around. I guess time stood still, a king without his crown. Now I'm breaking, you're faking, girl. You never made a sound. I'm tired of the pain. Go away. I'm tired of yesterday. Fada, fada. Yeah. open eye, feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you can make me move. You can make me move. Can make me move. You can make me move. Can make me. So alive, make it last forever. Stop in time, yeah, I'm surrendering. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you can make me move. You can make me move. Can make me move. Can make me move. You can make me move. Can make me. Can make me move. You can make me move. Can make me.
I'm alone, I'm a broken home. I gave you all the bricks that I own and know. I'm letting go, I'm breaking these walls down, breaking these walls down. If you want adventure, then fly to home. But if you wanna travel, then go alone. Yeah, what's the point in us if I never know? Yeah, if you're gonna leave, I'ma let you go. I'm tired of the pain. Go away. I'm tired of yesterday. Harder. I fell where my demons dwell. My own little nightmare, I call it hell. Oh well, it's time to get back up. Climbing and climbing, I'm done with this ride, is what I tell myself, so I could feel something else. Yeah, I guess I had my bad days. mistakes, but it doesn't mean I lost my style. Darling, where were you when my heart was on the ground? I thought time would prove that you would stick around. I guess time starts down, a king without his crown. Now I'm breaking and you're faking, girl. You never made a sound. Oh, wait, I'm tired of the pain.
open eye, feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you can make me move. You can make me move. Can make me move. You can make me move. Can make me. So alive, make it last forever. Stop in time, yeah, I'm surrendering. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you can make me move. You can make me move. Can make me move. Can make me move. You can make me move. Can make me.
I'm alone, I'm a broken home. I gave you all the bricks that I own and know. I'm letting go, I'm breaking these walls down, breaking these walls down. If you want adventure, then fly to home. But if you wanna travel, then go alone. Yeah, what's the point in us if I never know? Yeah, if you're gonna leave, I'ma let you go. I'm tired of the pain. Go away. I'm tired of yesterday. I fell where my demons dwell. My own little nightmare, I call it hell. Oh well, it's time to get back up. Climbing and climbing, I'm done with this ride, is what I tell myself, so I could feel something else. Yeah, I guess I had my bad days, but it doesn't mean I lost my style. Darling, where were you when my heart was on the ground? I thought time would prove that you would stick around. I guess time starts down, a king without his crown. Now I'm breaking and you're faking, girl. You never made a sound. I'm tired of the pain. Go away. I'm drawing yesterday.
Okay, so we are back here, guys. I will put the music here, the background music. Um, let's go. Let's go with what we were doing before. So, if I'm not wrong, we were checking out this the flag, this mask over here, right? We were looking at this value here, this invalid matching frame number. It seems like an invalid matching frame number would be something like this or this, but I don't really know where is getting this definition of invalid matching frame. We'll have to see where it comes from. Let me check the includes so I can. Okay, so it's including it's not including must be some include like this somewhere. No, it's not here. It's importing this contour. I don't know. No, it's not importing this same contour. So okay, so here they are defining this as an unsigned long but I don't really know. Are they comparing this to invalid matching frame number? I don't know. I will ask for this. According to definition of invalid matching frame number, so copy this. I will paste this here. Let's see if I get something. Okay. For some reason is just lagging this page. I don't know. Well, let's see what AI is saying. So the code need to provide extracts the interior frame number for a type safe matching frame number. Using hypervisor, we're using the file. Service status and the value located and by memory. This is themes type safe macro to check if the current matching frame number is not equals to this. The condition is true, the matching frame number is valid. It invokes the matching frame number wrapper locker to extract the raw integer. Yeah, but this is not what I'm looking for. I'm trying to figure out why using this macro instead of just defining, just using the direct value here. I don't really know. It's just weird for me. Anyways, I think I will define it. So yeah, I have some directory here. So we have already this type, so it won't be a problem. Okay, so invalid matching frame number would be something like this, right? Invalid matching frame number segment of 64 bits. This is very important, this part. We set this to the, I don't know if in Rust we can use this operator or not. I'm not sure actually. Operator is implemented for many primitive types. It's equivalent to the operator in C. Okay, so I can use directly this not operator to this value, right? Because if I do this, then I will get I will check it out. Play around maybe with this. I can define this code. Equals to negate 0. Let me see what it prints. Oh yeah, it works. I didn't expect that actually. I thought that I would have to do this the binary value, you know, with like this, but no, it worked. Okay. Okay, so we record this like this, and we have to do this function also. I didn't expect this to be an inline function instead of a macro. Yeah, I didn't expect that. Okay, so now I will do the same thing. I think that I can say matching frame number equals, okay. So this function matching frame number equals, okay. And okay, there's 2 params here. I think this here, and I receive this here. return. Okay, this will return a boolean value. I will check if x, in this case, is using this macro over here. I don't really know what is the use of this macro. Okay, so this will be something I have to check this macro. I don't really know where it comes from because I'm seeing the definition here, but this is not the actual definition for this macro. I can't find where it's defined, so nah, I'm not finding it. I'm not finding anything. No, I won't find this definition. I think this is the definition for this macro, but it's supposed to be somewhere above. So I don't know. It's just confusing. You know. Right, well now I will use these values like this. So I have to check the in Rust we don't have this ternary operation, which kind of sucks actually, because you know, this is something that would be really good for Rust to have. I don't know if in a nightly version of Rust we have the ternary operator. So Rust does not have ternary operator. You could also create a macro to generate the if-else code for you. Yeah, I think this is a good implementation. Please. I don't know much of how to create macros, but yeah, I think this. Okay, so Yeah, this person has actually a point, but I don't know. For me, it's more like visual to see this rather than this thing over here. But that's just my opinion, right? So I don't think I actually I don't think it's worth it to create a new macro just for this. So I will refuse and just this expression. Okay, so what we have to do here now is comparison, right? What we are doing is so do is something like this, like um if I'm not importing this. Okay, yeah, I'm importing it. So perfect. I will use this. What did I call it? Okay. Matching frame number. And then I will pass here the parameters. The first one will be the matching frame number that we are receiving here, and the second one will be this invalid matching frame number that we defined here. I will copy it. I will go here, and then I will paste this like this. Oh no, it copied everything. I will just type it. Where else? What else? I'm gonna use this matching frame number, and in the other case we will be using this 0 value. Okay, so now I have to apply this or operation. Let me put this as a summutable variable. Okay, we have to apply an OR operation to this. So let's see. Where are we applying this the virtual frame number to the mask? We clarified previously that this was doing if we have the super mapping bit enabled, then we will just use this matching frame number, and in the other case we'll be using this zero value. But I don't know when it's applying this virtual frame number to the mask. I don't really know the reason. If we converted the previous virtual frame number, oh no. Why are they doing this? What are they trying to do with this OR operation, applying the virtual frame number to the mask? Likes on page look. No, this is right. This is what we're doing here. This comparison. We'd have to take the mask and like this and use this first person here. I don't know what this bit first order means actually. I will look for the definition of this. So insert string bit, define bit. Maybe it's a new extension. No, it doesn't seem to be a new extension. So so then where does this comes from? Find bit. I have a bare metal software environment that can compile and that can compile run on multiple architectures such as around 32 minutes, 27 custom house architecture. I've implemented a bit macro. Now on ArtX is using bit on it. I can't find this bit definition, so I will ignore it just for now. What I'm interested in is in this first order macro. It seems like it calls this some pretty level order to 1, right? And this applies the let's see, this number up to 32-bit. The silhouette level does not exist, therefore the total final bits. There are B7 architecture actually specifies a 40-bit input address space for the 2M. Number would be, what was the number? Now I have my doubts. What was the number? Let me check it out. I don't know the reason of this comparison here. So we'll copy all this. I'll search for the will search for this bit for here. Okay. So it returns here this. It will be something like this in my case. Case it will be something like this. I guess would be something like the number, just the number. I would return another number. And then basically return this. Let me find it in another place, like for example in here, for example. Looks like something is aligned. Okay, this is not the correct definition. No, this is not the correct definition. This would be the correct definition. I don't know if this would go in memory stuff or I think it would go here, right? Yeah, definitely it would go here. So so what they are doing is call this first order. I don't know what this first order means. I don't have the slightest of the slight idea of what this first order means. order, yes. What does this level order, yes, do? Huh? Level order, yes. But it does this thing. Wow. Okay, now. I think this is for the large page address extensions, because in comparing the normal zips, the normal zips, I mean without the large page address extension, to the zips with the large page address extension, the bits would be different, right? So if I'm here these macros for the case that we have large space address extension activated, so that's actually not something of our concern now, because we don't activate this large page extension bit, but in the future I think that I will use it, but I don't know if it's worth it to fight with these definitions now. I need to understand what it's doing here, and I get a brief idea by looking at this. I think it's carrying the bit, is carrying the bit depending of the level, right? By the first level order. So those are the flags bits, I think. Number is comparing if number is greater or equals to this thing. Only if I know what this means, I would. So it's trying to figure out if the level is the level 1, right? What do we need to check if the level is the level 1? We need to good question. To check if the level is the level 1, I already know. I don't actually know. I'm stuck with this part of here. I don't fully understand what this first order means. The mask. The mask. The mask would be this that we defined here, but I don't know what is checking with this, but before, you know what, I will assume that it's always the level 3, and then I will care about, I will see these macros over here, because I don't want to waste more time with something that has a feature that I don't have. So I will just get to the point. I will assume that this will be always the level 3 instead of checking it. So we comment this, and I will go here. I will define this like the level 3, and I will type here a to-do. Check the current level. check the current level, we have to activate. Very important to use call for the so once that we define the mapping level thing, we'll use the we will go to the pt update function we were working on previously. So okay, so the next step would be you see that here we have two iterations, right? One for this left and the other one for this number contiguous. And the reason is what I explained previously about the contiguous blocks. So it basically starts with this with the first iteration goes here, it gets the contiguous blocks, and then it starts to map all the contiguous blocks, right? And if it didn't finish, it will go and do and repeat the same thing here, and it will map contiguous blocks until it finishes, right? So we need to do something similar to this. I will have to investigate about this thing that they call order, because I don't actually get what it means. I guess that it's something for the a term that they use for instead of level for the when they are working with addresses that has the large base address extensions. So I will go to the next step. That would be basically this function over here, the send pt check config. So we need to do something similar to it. So we'll close all of these tabs. I will search for this function. Here we have it. Check where the contiguous bit can be set. Return the number of contiguous entry allowed. If not allowed, return 1. As simple as that. So okay, so the first thing that it does is basically declares this number contiguous, then it checks the flags and this page block. Remember that this page block was the macro that defined it. If we hold here to definition the bit 7 of this map, the bit 7 of this map where it basically checks if the super page mappings, right? If we have this feature, and for some reason we can't do this if we have the super page mappings. So we'll have also to investigate what this super page mapping means, because it is obviously not the same thing as the contiguous thing. So let's see. And now we'll just do the same thing, like checking this bit, and if it has this bit, I will return also this this code. So why do we need all these arguments here? I don't really get it. Okay, I get that we need the virtual frame number, but in order to enable the contiguous bit, we should have enough entries to map left, and both the virtual and physical address should be aligned to the size of 16 translation tables entries. Okay, that makes sense. So now we will receive also the What is the level? The current level. So sorry, this would be actually something like this. No, and no, this left would be before. These flags would be all the flags would be also 32 bits. Okay, no, what we're checking is if this bit is not activated. So yeah, the super mapping, the super page mapping is the bit that we need to activate to use the contiguous regions. So yeah, that's related to it. I thought it didn't have anything to do with the contiguous thing, but it does. Okay, so first check if the flags and pigs work. Oh no. maximum frame number, we have to type same byte maximum frame number. So the creator would be also returning one. So so this is like a kind of assert maybe to check if the page size is using 4 kilobytes for the granularity. So let me check it out. Must be something here that defines this build back on. Okay, so it's defined here. It uses this static assert. I don't know where they define it. Let's see. I will close all these windows. In these previous days I was looking for some articles, but I don't want this anymore. So there are muffins when this is something important, so yeah, I will keep it. Okay, this is important, this is important, this is important. Okay. So let's search for this static assert. Static assert, where is it defined? No, it is not defined anywhere. What? It's a built-in keyword used to test condition in compile time. This introducing C11 standard as static assert. The assert.h header also provides a static assert as convenient macro that maps this to this keyword. Oh, validates that the size of an integer is started 4 bytes. Okay. Rest. how this is possible. Rigid, so oh, so this is not implemented yet. Ah, damn it. So we have to use either this or this. Guys, I'm kind of tired and I think I will have to go to sleep, so I think this is it for today. So well, see you tomorrow.